Hi everybody, this video is going to go through the examples covered on worksheet number 5. So this worksheet, the main concept in this worksheet is we are dealing with both the x direction and the y direction. So if you project something horizontally, that's like, you throw it across, but yet it's also going to go down. And so it has an x component and a y component to it. And so that's exactly what this first problem deals with. A rock is thrown horizontally off a cliff at 100 meters per second. It lands on the ground 10 seconds later. So I can actually use this visual and turn it into a little bit of a graph. So for instance, if I change this into a graph, the y-axis is my height, the x-axis is my time. The problem says it takes 10 seconds, and the problem says it was launched with a velocity of 100 meters per second. That velocity is the x component of the launch velocity. So I've labeled that v sub ox to verify that as the x. Let's talk about, well, for one, I said v sub ox, and here they say v sub xo. Really, the subscripts, I think either order is fine. But let's talk about those subscripts. Is that, for instance, on this first one, we have a sub x and a sub x and a sub x. We actually could say that exact same equation with a sub y each time. So but you have to keep them separate. But there's another equation that's not written, which is v sub y equals v sub y original plus a sub y times time. We just don't have it written out on the formula sheet. It's just kind of understood that you realize both options would work. Same thing here, like I have an x, a v sub x, etc. All of those x's I could change into y's instead, and it still is a valid equation with y and y sub naught and v of the y direction, etc. So just realize that even though on the formula sheet they have the x direction, those same formulas apply in the y direction. Okay, so let's go back to our question is how high is the cliff? So that's what we're looking for, is how high is it? We don't know. But we do know what its launch velocity was, and we do know what the time is. Okay, we need to read through here and start defining some variables. On the AP test, we can always use negative 10 meters per second squared. In our in-class calculations, I typically use negative 9.8. On this one, I'm being a little bit lazy and using negative 10. Also, when we're doing labs, you absolutely have to use negative 9.8 on labs because we want to be as accurate as possible. Negative 10 is not close enough on the labs. All right, but we do know that the acceleration, and if we wanted to call that acceleration in the y direction, we could, or we could call it acceleration due to gravity, whatever, is negative 10 meters per second squared. The time is given to us as 10 seconds. Velocity original, actually, okay, let's go back. All of these things are y's because the height, that's a y direction, right? Okay, so why did I say that the original velocity, the initial velocity is 0, when over here I said it was 100? Well, because actually the y direction is 0. The second that rock is launched, it does not have any vertical velocity at all. Now, by the time it gets to the bottom, yes, it will. It's going to hit someone hard if someone's in the way. But initially, in just that precise moment where it leaves the hand of the thrower, it does not have any y velocity. And so this v sub o is actually the y direction, is 0. And that's a delta. It's best I could do for now. So that's our delta y. That's what we're looking for. Okay, so now if we look at our equations, I have our 3 equations up here, and we have to decide which one to use. So this first equation has some velocities in it, has acceleration, has time, but it doesn't have the height. I need the height. And so here it's y, but it could be x. So this one is a possibility because it has the x. It actually looks like a good possibility. This one requires us to have a final velocity, which we do not know. Now, we could calculate it, but we don't know it yet, so I'm not going to use this one. I'm going to use the second equation. When I use this equation, I like to subtract that x sub o to the other side, and we're going to be using y's, not x's, and so I'm going to call this delta y is equal to. Now, in the y direction, which is what we're dealing with, our initial velocity was 0. but we do need to calculate with our 1/2 at squared. So our a in the y direction, not the x direction, is negative 10 meters per second squared. So I'm going to plug in my velocity, or excuse me, my acceleration and my time, which I know. So now I just need to go to my calculator and calculate this. And so that to me looks like a negative 500 meters. Remember, as far as my units go, this second squared is in the denominator, this second squared is in the numerator, so what I'm left with is meters. Okay, my delta y is negative 500 meters. Why is it negative? Well, it's negative because it fell 500 feet. It went down 500 feet. So the question is, how high is the cliff? Well, the cliff is just 500 meters high. The distance, the delta, is negative because it fell 500 meters. But the answer to this question is 500 meters. Okay, let's look at the next question. How far from the base of the cliff does it land? Okay, now we actually do want that distance over here. Instead of time, we're needing to figure out the distance. Well, how are we going to figure that out? Let's go back to our variables and see what we have. Now, one thing is this time we're dealing with x's. How far from the base? We're talking about the x direction. So now all of these numbers that we have need to be in the x direction. So the acceleration in the x direction is 0. Because I don't know if you remembered, we talked about when you toss something or anything that's moving in a horizontal direction will not change velocity. That will be a constant velocity the whole time, unless something stops it. Otherwise, it's going to have a constant velocity. If it has a constant velocity, it does not have an acceleration. In fact, that velocity, both the initial and the final, in the x direction, are both 100 meters per second. It's not going to slow down, it's not going to speed up. The time is 10 seconds. We are looking for the change in x. How far does it go? All right, once again, I'm going to go to my equations and decide which one to use. Once again, I think that this middle equation is the one, so I'm going to use it. And the reason I'm choosing this one, again, it's going to give me the delta x. That's what I'm looking for. I know my velocity, I know my acceleration, so this is going to be a good one to use. So again, I'm going to subtract that x naught to the other side, and that gives me a delta x. And now my initial velocity does not get canceled. I actually have an initial velocity of 100 meters per second. And my time is still 10 seconds. Then my acceleration, though, that one is 0. So that one does drop off. Once again, I want to pay attention to my units. Seconds and seconds go away, and I'm left with 1,000 meters. So that is my distance. How far from the base of the cliff does it land? 1,000 meters. Okay, let's look at the next section. What is the horizontal component of the final velocity the instant before it lands? Well, we just talked about that. I don't know if you realize it, we just talked about it. When it lands, it's going to have a vertical velocity to it, absolutely, and it will have a horizontal velocity to it. Its final velocity in the x direction is the same as the initial velocity. Unless something gets in its way, it is not going to change. All right, next question. What is the vertical component of the final velocity the instant before it lands? So once again, we're talking about right here when it lands, how fast is it going downwards? Now, how fast is it going across? We already know that. We want to know how fast is it going down. So once again, let's take a look at our variables, see what we have. Okay, I'm talking about the vertical component. I'm talking about my y components. So acceleration in the y direction is negative 10 meters per second squared. Still have 10 seconds. Initial velocity in the y direction, we talked about that, is 0. Because when you drop it, the instant you drop it, it's not going in the y direction. After an instant, it is. And we want to know what it is its final velocity. Okay, looking at these, it seems like we have a pretty good equation we can use for that. So this one is pretty straightforward. Again, instead of the y's, we're going to be using, instead of the x's, we're going to be using the y's. So we're looking for our final velocity, and our initial is 0, and our acceleration is negative 10 meters per second squared, and our time is 10 seconds. So our final velocity in the x direction is 100, negative 100. The seconds and seconds squared and this seconds, one of them is going to cancel off with the other one, and so we're left with a negative 100 meters per second. Why is it negative? Because it's going down. If it's going down, it's negative. Okay, so now we get to part E, which is asking for the overall velocity, because part C asks for horizontal, part D asks for vertical. Now we need to put those together. How do we put those together? With vector addition. So if we go back to our diagram, the overall velocity, we know that there is an x component of the velocity and there is a y component of the velocity. To use vector addition, which is what we need to do, we need to put these tip to tail, right? So we need to move it over here just so we have it tip to tail. And now what we're going to look at is the resultant vector, which is over here. Okay, well, how long is each of these vectors, each of the components? Well, 100 in the x direction and negative 100 in the y direction. And so to find that, that's going to be a Pythagorean theorem problem. So our net velocity, our total velocity, adding both of those components together is going to be 141.4 meters per second. So that's our magnitude. That's how big it is. That's what magnitude means. The direction is, what direction is it going? Well, aren't these equal length? And so isn't that a 45-degree angle? Now, we should say north of south or south of north or whatever, but we don't really know what direction. So maybe we can just say below the horizon or below, yeah, we can say that below the horizon. All right, that example was one where we were given some information and we had to find the velocity. The next question is similar, but it is not velocity. We're going to be looking at some other things. So let's take a look. This time we have a rocket, and the rocket gets launched horizontally off of the building at 1,000 meters per second. So that is our initial velocity in the x direction. And then they tell us it lands 2,000 meters from the base of the building. So this time we don't know the time, but we know if this was just distance, just a drawing, that this would be 2,000 meters away. So the question is, how long was it in the air? Well, since we are talking about the x direction, we know that that is a constant x velocity, right? That velocity does not ever change. And so this question, even though it's asking about how long was it in the air, which is kind of asking like when does it fall in a way, but we know that constant velocity and we know the distance. So it doesn't really matter if it's thrown through the air or if it's rolled on the ground. Either one, the height doesn't really matter. We want it because we've got that distance over here. So I'm going to go back to our basic velocity equation. Average velocity is change in x over change in time, because our velocity, our x direction velocity, never changes. So our x direction velocity is always 1,000 meters per second. And we know that the change in x is 2,000 meters, and time is what we're looking for. Sometimes people get confused when the variable's in the denominator. One thing is you can think about it logically. 2,000 divided by what would give you 1,000? Hopefully we all can see that the time would be 2 seconds there. But if you just want some help on how do I do that with algebra, because you have a hard time with that, what I would say is multiply both sides times t. And when you do that, I'm going to need some space here. When you do that, you're going to get 1,000 t on the left and 2,000 on the right. And now we divide by 1,000. And so that does give us t equals 2. So that's how you do it algebraically, but if you're just able to do it mentally, that's fine too. So it is in the air for 2 seconds. We're going to need that bit of information. Now, how high is the building? In this case now, we're switching gears and we are talking about the y direction because we're talking about height. So anytime we talk about height, we have to talk about the y direction. So how high is the building? Well, let's go back, see what our variables are, and decide which equation to use. In the y direction, the initial velocity, the instant it leaves the rocket launcher, is 0. Now, as it gets closer to the ground, it's going to gain some velocity, right? But at the beginning, it is 0. We do not know what the final velocity is. We could find it, but we don't know it yet. And the question, delta y, that's how high it is, that's what we're looking for. So now we have to go back, look at our equations, and decide which one to use. I'm getting kind of crunched for space, so I'm bringing it over here. So we're talking about height, which is the y, not the x's, but this is the equation that will work for us. I'm going to subtract that x sub naught and make it a y instead, so I'm going to call it delta y. Now, our initial velocity is 0. And now we just have the 1/2 at squared. And so I multiply that out, and I get negative 20 meters, because these second squares and these second squares basically cancel each other out, and you're left with negative 20 meters. Why is it negative? Because we just calculated the delta, how far it went, and it went down. And so it is 20 meters down. How high is the building? The building itself is 20 meters tall. Okay, last question, but it is a big question. And I say it's a big question because they have the question, what velocity does it land? And they didn't break it up between x direction and y direction, but we need to. But we know that the x direction velocity never changes. So whenever it started at, that's also what it's going to end at in the x direction. So this is going to end at 1,000 meters per second as far as the x direction goes. Well, what about the y direction? That's the one we need to talk about a little bit. Okay, so let's look at our variables. Once again, right now we're focusing on the y's because we already know the x. So the acceleration in the y direction is negative 10. Time is 2 seconds. We already figured that out up here. Initial y velocity is 0. We do need to find the x velocity. Delta y in this case, I don't think we even need it. I mean, we have it. It's 20 meters. I guess we can write it down. But we don't really need it. Because I can tell that we have enough, that VF equals VOAT is all we need here. And again, these are in the y direction. Let's just keep that in mind. So our final y, that's what we're looking for. Our initial y was 0. Our acceleration is negative 10 meters per second squared, and our time is 2 seconds. And so when I multiply that out, I get a negative 20 meters per second. That's not my final answer. I need my total velocity. But I have my x velocity and I have my y velocity, so now I need to do some vector addition to add those together. All right, so I need to do my Pythagorean theorem. The ones I'm using this x direction and this y direction. I'm going to do the Pythagorean theorem. And so my total velocity is 1,000.2 meters per second. I probably should calculate my direction, right? It doesn't say to, but velocity does imply direction. Let me just talk a little bit about this first, and we'll talk about direction. With this, notice most of the velocity is coming from the x direction. There is a little bit in the y direction, but again, this was a rocket. It was getting shot really fast. So most of the velocity is coming from the x direction. That 0.2 is basically just this little piece getting added onto the end. Okay, as far as our direction goes, so we know it's going 1,000 meters per second this way, and it's going down 20 meters per second this way. So I'm looking for this angle in here. That's a tiny little angle, right? So for this angle, we're going to find the inverse tangent of opposite over adjacent. And my calculator might not like that negative, so I'm going to go and change that just because it wouldn't matter if it was positive, right? If it was going the other way, it'd be the same thing. So we can do that with our angles. So we're going to put that into my calculator. Make sure you're in degree mode. And when you plug that in, you should get we'll call that 1.15 degree. Mostly horizontal, right? There's not a whole lot of vertical to it. It's going to be like skidding on the ground when it lands. So 1.15 degrees, and we will call that below the horizon. Okay, a little bit of examples on some two-dimensional motion, some projectile motion. we will have more practice on this with our AP questions.